Hey guys, I got a ton of questions last week about statistics, and please doing a video on this quiz. People were running out of time. People weren't getting concepts. I got it. Statistics can be scary. I'm here to help you through this. I know this isn't going to win me an Academy Award, these videos, but do the best you can by pausing it, reading it, doing things that can be helpful for you. All right. So one of the questions I got was from a number of students was help on calculators and how to do the formulas. Well, I'm going to give you some calculators and help you with some formulas. So our first question on that quiz is going to be a question of is there going to be some type of coefficient? What's a correlation? Correlation basically tells us if that is true, their hypothesis. Do we need to dig deeper into this analysis? A whole bunch of cool things happen with our sample correlation. So we're going to try to find a coefficient R. So it is a thought that prehistoric Indians did not take their best tools when they visited higher elevation for summer. They hypothesized archaeological sites tend to lose their cultural identity and specific cultural affiliation as the sorry, that's a hard word to say. Elevation of the sites increase. So let X be the elevation, the archaeological site, Southwest United States. Let Y be percentage of unidentified artifacts, no specific culture, and suppose the following is going into New Mexico. Here's a great tool. I use this. It's a social science statistics calculator. Here's the website. I'm going to put this into the video link as announcement as well so that you have it here. All right. So the first one that we're going to go down to is we're going to go to our linear regression calculator. All right. Our linear regression calculator. Sorry. We're going to go to our person correlation calculator. I forgot. The first one we're doing the correlation coefficient of R. All right, cool. It gives it, here's everything that you need to do. That is an ugly equation. I'm glad that I don't have to do that anymore because we have the internet and we have great computers to help us. So look, take me to the calculator. I'm going to go ahead. You can read all this as you're going through this and studying for this exam. I'm just going to go ahead and type this in. I would do this before you take the quiz. Save you some time on there, and then 7.75, and then I'm going to put 8.5, and then my Y values are 4, 52, 43, 53, and 91, and I'm going to push calculate R because that's what we're looking for. And so we're looking here it is, the R value is 0.749. That's going to tell us that there is a probable reason that this hypothesis is good. Not meaning that it's right, we're just thinking that there is a correlation between the X values and Y values. Not a lot of data. Here's our chart, and kind of maybe like a right there, a line in between there. So yeah, it does make sense for that. You can read all this information here, help you understand this question a little bit better. All right, so let's go back to our calculators here. And then we're going to go to question number 2. Question number 2 is doing something very similar, but we're finding the linear regression here. So we're going to go ahead and find out why this is important. So as we're looking at this, we're looking for the B in the line. Okay, so a line has an equation of y equals a plus bx. We have all that information, but what I need to do is to find the linear for the B. The linear regression variable comes in here. To help us, I can type this in. Please note that these numbers did change slightly. Kind of annoying that they did that, but we can't cut and paste. But it's okay. We can just type it in. We're going to do this before we take the quiz anyway, hopefully, and so that you can read about it and answer it, the question, and get going on that. All right. So skip all the estimate part and let's go calculate that regression part, and then there is our answer there, because that is the equation, all right, that we are looking for, and that is our negative 81.5 0.093, and that helps us form the line. So y equals 20 in there to help us, and that gets us that information. All right, now question 3. Whoa, this is a hard one, okay, guys? And our calculators really can't help us that much on doing that, but we can put in information here as well. So let's go in there and look at that. And if we look, and we just go back over here and we look here, the numbers did change as well, okay? And so what we're looking for here, we can go ahead and put our 5.75, 6.25, 7.25, 8.25. And we can do this in Excel too, but it's just easier with having the calculators on here and doing it like this, because then we don't have to really put the formula of the calculators doing that. We can go in here and type in calculate our regression model in here, and we have a line that's coming in here, all right? And now we're going to have to dissect something here, okay? What we're really dissecting is, and it's hard because this question is going to ask you what percentage of the variation in y cannot be explained by the corresponding variations in x and at least square lines. I'm going to give you the answer here, all right? Because you're not going to have time to calculate this on there. So the answer is 18.2, all right, percent. 18.2%. I just don't like this question. I think it's a little bit of a tricky question for you because you have to look at all the other answers to find out why or which one can this not be, all right? So the answer there is 18.2%. All right, now I'm going to go ahead and make my screen a little bit bigger for my, oops. I'm going to make my screen just a little bit bigger for my PowerPoint because we're going to move into probability. This is my favorite part about statistics. So if the probability, and it starts off with a really easy question, if the probability that an event will happen is 27%, what is the probability that the event won't happen? So probably in high school I had a 27% chance of getting a date, right? So the probability of me not getting a date was the opposite, so I would subtract 27 from 1, or 100%, and that would be 73%, or 0.73, or 73%. All right, so a coin is being tossed 1,000 times. What's the probability that the 785th toss is heads? Well, what's the probability of the 786th toss being tails? Who knows? But we do know that we just have a probability of one or the other. It's going to be heads or tails. So it is either 1/2 or 50%. Tried a tricky question right there just so that you understand the differences there. Don't like that question because I don't like when tests try to trick you, especially when third times they can get kind of hard. All right, so there are 12 qualified applicants for 3 training positions in a fast food management program. How many different groups of the trainees can be selected? All right, so crazy question here, right? So there are 12 qualified applicants, right? And for 3 trainee positions. Looking at these for the 12 qualified applicants for the 3 trainee positions, what we're going to do is how many different groups of trainees can be selected. So let's go ahead and look at this. And what we're going to do is we're going to take 12 and we're going to divide it by or let me get you the better one for this. So that's our equation there. All right. From doing this, what we're going to do is that we're going to look at how we are going to correct this in a way so that we can find each group. All right. And so in doing that is that I have 12 times, 11 times 10 times 9. All right. That's for the top one. Okay. The next part of this is what we're going to do is that we're going to look at how we can figure out how we get the top part. All right. So we have the 9. So we can just cross off this 9 up there because we'll get rid of it here. And so we have 3. So we have 3 times 2 times 3. Just put a line there. Correct my grammar there. All right. So here is our chart. So if we go ahead and we calculate this out, we have 12 times 11 times 10. And then we look at that and we divide that by 6. Because 2 times 3 is 6, we get a 220 answer. A little confusing, but not too hard. All right. So you have a couple of questions like that you're going to have to look at. All right. Here's some hard questions, okay? A little bit more difficult questions. So let's say that there are 4 radar stations and the probability of a single radar section detecting the enemy is 0.85 or 85%. What is the probability that 3 stations detecting an enemy plane? Please answer your question to the nearest 100. All right, let's go ahead and let's do this one. All right, so the first thing we're going to do is we're going to take 3 times 0.85 and we get 2.55. In there is we take 2.55 and divide that by 4 and we get our 63.75. Or sorry, let me go ahead and make it more accurate. 0.6375. Then we're going to take 1.6375, and that would equal our answer. And our answer would be here, rounded to the nearest 100, 0.37. All right. So that's how we would do that one. This one is just asking for the reverse. So there are 5 radar stations here, and the probability of a single radar station detecting an enemy plane is 0.65, and the probability of not detecting a plane, what is the probability of the number of stations that detect a plane is no more than 2, rounded to the nearest 100. You're going to have to calculate that similar to the way I did it above. I'm not going to give you the answer to that one, but I'm going to give you the question ahead of time so you can work on it in there. All right. If you have any questions or concerns, let me know. I'm here to help.